There's a problem with Psyche's propellant fuel lines. Have astronomers found the first hint of Planet 9? How Kerbal Space Program could help space agencies design real missions, and gold from magnetars. And in our longer Space Bites Plus edition on Patreon, a Soviet Venus mission will be re-entering the atmosphere in May. All this and more in this week's Space Bites. So there's a problem with the Psyche mission. And for those of you who aren't aware, Psyche is a NASA mission that is going to an asteroid called Psyche. It is not confusing in the least. Now, Psyche has been in space for well over a year. It's done some incredible tests of a high-speed laser transmitter system, but the final goal is for it to reach this metal asteroid named Psyche. And if we're really lucky, this asteroid is going to have evidence of metal volcanoes. It's thought that this world was once the core of a larger planet, and then it got into some giant mix-up, and you're left with just the exposed core of a planetoid. But there's a problem with Psyche. And the problem is that the fuel pressure in its lines is low. So Psyche is equipped with ion engines. These, of course, are where you have this electric field that accelerates ions, in this case, xenon gas, out the back of the spacecraft, and then the spacecraft gets a kick in the opposite direction. It's very fuel efficient, and these engines can run for long periods of time. Psyche started up its ion engines a year ago, and then in early April, engineers at NASA detected that there was a decreased fuel pressure in the lines. Now, Psyche detected this as well, automatically shut down its thrusting, and this gave the engineers a chance to try and figure out what the problem is. There's about 2 months until the loss of the trajectory builds up to the point that there's a problem. So there's plenty of time for them to try and troubleshoot the issue. And the other piece of good news is that Psyche actually has a redundant fuel line. And so this is a problem with the main fuel line, but the engineers know that if worse comes to worse, they can just switch over to the backup. But they want to figure out the problem. Better to make sure that you've solved the problem with the main one before you have to go and use the redundant second version. But it's just such a great example. Imagine if your car had a redundant fuel line and you knew that, if there's some problem with your fuel line, you just switch to the backup. And these are the kinds of decision choices that people who are working on missions that are really far away from Earth and we can't actually connect with them, they have to go through. So we'll keep you posted when either they solve the problem or they switch to the backup fuel line. A possible hint for Planet 9. Mike Brown and Konstantin Batygin are two planetary scientists. Mike Brown is the famous Pluto killer. He's the one who found Eris and a lot of other dwarf planets in the outer solar system, and this led to the demotion of Pluto. But Brown and Batygin have been mapping the locations of objects in the Kuiper Belt, and they noticed that there is this strange clustering, some kind of disturbance that is happening to their orbits. And they propose that there is a large object out in the Kuiper Belt, something that is maybe Earth-sized or maybe even Neptune-sized out there, hundreds of astronomical units away from us. And it is affecting the gravity. It is disturbing the gravity and the motions of all of these objects out there in the Kuiper Belt. But nobody has been able to find it. And that's because it's very far away and it's probably very dim. And space is very big. And so far, people have done lots of surveys. They've tried to find it. Nobody has been able to find it so far. And we're kind of waiting on the Vera Rubin telescope to finally come online, and then that'll be the one that will probably find Planet 9. But they realized there was a pair of surveys in the far infrared that were taken 23 years apart. And this is both the right wavelength to search for a cool object in the outer solar system, but also enough time to watch the movement of anything in that area. And so they looked through the IRAS survey and the Akari survey. And with those two surveys, they were able to identify 13 candidate objects that have the right size, temperature, speed, and other things that they were looking for that had moved along the right orbit within that period. And then they crunched the data, removed false positives, and they got down to one candidate object that still met all of that criteria and seems to actually be out there. But both the IRAS and the Akari surveys are just not good enough for them to be able to confirm that, yes, they did indeed find Planet 9. So they're going to need to do follow-on surveys. They're hoping to use a bunch of upcoming instruments, and maybe if they're able to find the actual precise object, we could see some follow-on observations with James Webb. So This is not proof of Planet 9, but it is an intriguing candidate. We've got a great story about this from Mark Thompson on universetoday.com. A rare occultation for Uranus tells us so much. There's a really interesting way that objects can align in the sky that tells us a tremendous amount, and these are called occultations. Now, an occultation really is when something passes in front of something else. It occults it. And so when you have, say, a solar eclipse, the moon passes in front of the sun, and that is an occultation of the sun. But one that astronomers use all the time is called a stellar occultation. And this is where you've got a bunch of stars that are in the background, hundreds of light years away, and then some object passes in front of them. So for example, you could have an asteroid passing in front of a star, or a planet passing in front of the star. And when this occultation happens, then you learn a tremendous amount about the object that is doing the occulting, the asteroid, the planet, the comet, whatever. For example, astronomers have found moons for asteroids and rings for asteroids in the past just because they watched the light curve as this object is passing in front of the star. And so there was a really important occultation that was going to be seen in early April to observers in North America, an occultation by Uranus. So in other words, Uranus was going to pass in front of a star, and as it did, the star was going to disappear behind the limb of Uranus, and then it was going to reappear again. These things are incredibly precise, that it was only visible from North America, that the angle of the star and Uranus and Earth have to line up perfectly. It's only visible for small parts of the planet. And each person who's observing it from different locations sees a slightly different view. And so astronomers in the US teamed up. You had 30 astronomers at 18 different observatories make their observations at the same time, watching as Uranus passed in front of the star. And they were able to measure the brightness of the star as it was obscured by different layers of the atmosphere of Uranus. Now, they're still going to be crunching the data, and eventually we will find out a lot of new information about the lower levels of Uranus's upper atmosphere. But it's amazing that you can get these sort of chance encounters and be able to learn a lot more about the object that is passing in front. And if you want more information, we've got an article by Matt Williams on Universe Today. How Kerbal Space Program is inspiring real missions. I've always said that I learned more about orbital mechanics by playing Kerbal Space Program than I did for decades of doing space journalism. It's one thing to understand different orbits and orbital insertion maneuvers and landings and things like that. And it's another thing to design the spacecraft that is actually supposed to perform this, to do your insertion burn, to be able to move into a different orbit. It's an incredible learning experience. And now, as I learn about various missions, it's this Kerbal Space Program knowledge that has taught me a lot of this. But I'm sure for many people who are working on Kerbal Space Program, you're aware of all of the really clever solutions that people have come up with to solve problems. In many cases, to recreate existing missions and maybe even come up with new ideas for missions that could be more efficient or use reusable technology and things like that. And so a team of engineers also agree with you that there's real potential here. Now, part of the problem is that the Kerbal Space Program isn't realistic enough. They wave away a lot of the detailed physics of spaceflight, but there are mods that can bring this back. There's one called the Realism Overhaul, where they were able to add a lot more realistic information about fuel and propellant and weights and drag and all this kind of stuff to make it a lot more realistic. And so some researchers took the existing Artemis framework for NASA's return to the moon. All of the different kinds of rockets are going to be used, all of the stations that might be used, potential fuel depots, landers, and things like that. And then they used a version of the Kerbal Space Program where they put a more advanced realism modification on it. And they used another mod that allows them to then output all of the things that they learned into a form that they can then bring into their own actual simulations that are done for these kinds of missions. And what they found was that you could rapidly prototype different ideas and concepts in these mission plans and find out whether or not they're feasible to like a first order of certainty. And then you could pull that information out, put it into your more realistic simulations and find out if the prototypes that you developed were actually going to work in the real missions, and found this real use there. And so they propose that there will eventually be a much tighter coupling between these kinds of games that are made more realistic and then the actual kind of mission planning software that people at space agencies are using to design their actual missions. Now, I've got an interview with the lead researcher behind this paper, which you will probably see next week or the week after that. So stay tuned for that. And of course, if you want more information, we've got a much more detailed story about this by Matt Williams on Universe Today. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner this week was that astronomers have discovered a planet orbiting perpendicular to two brown dwarfs. So thank you everybody who took a second to vote. Now we will post the new poll to the post tab here on our channel within about 24 hours of when we release Space Bite. So if you're just scrolling on YouTube, go ahead and give us a vote. Now, of course, the best chance is make sure you're subscribed to the channel and you click on the notifications bell, and then you just do everything that the algorithm asks of you, and then you'll be able to see that poll. Gold from magnetars. So where do the heaviest elements in the universe come from? Things like gold, platinum, and so on. Astronomers used to think that they came from supernovae, that was the only place where you would have enough energy and density and heat to be able to fuse lighter elements into these heavier elements. But then we saw the kilonova. This is where we saw two neutron stars collide with each other, and astronomers detected the presence of enormous amounts of gold and other heavier elements in the wreckage from this thing expanding. The problem is that we can detect heavier elements in the universe that came from a time before you would expect to see these neutron stars start to collide with each other. So where did all this early heavy metal come from? And so researchers have proposed a new theory that they come from magnetars. Now, magnetars, a type of neutron star. They're what you get when a star with, say, 8 to 20 times the mass of the sun dies. It implodes, explodes as a supernova, and you're left with this neutron star remnant. And in some conditions, you get what is called a magnetar, where it is producing these enormous, very powerful magnetic fields all around it. And these magnetars are known for having starquakes, where you get this flash of radiation that comes off the surface where the magnetic field lines are connecting and reconnect. And researchers have figured out that during those starquakes, you can get the fusion of heavier elements. And you can also get the decay of heavier elements into lighter elements. And that because this is on the surface of a star, they are being thrown out into space, and these can be contributing to the amount of heavier elements that are in the universe. And they estimate that this could be responsible for, say, 10% of the gold in the universe. So gold coming from magnetars. And we've got a great story about this from Mark Thompson on Universe Today. All right, we've got a couple of stories about dark matter. So the first one is about the Perseus cluster, and this is one of the largest star clusters in the observable universe. There are thousands of galaxies that are collected together into this monster super city of galaxies. But astronomers recently discovered that there's a main central core, and then there is like a satellite galaxy cluster to its side. And one of the things that's really interesting is like, how do these two groups of galaxies, not stars, galaxies, connect to each other? And now researchers have been able to find a bridge of dark matter that connects these two. And this bridge of dark matter is very massive. It contains probably about 200 times the mass of the Milky Way. So it is very massive, and yet it is this tenuous structure that is connecting this larger galaxy cluster with this smaller satellite galaxy cluster. And we've got a story about this from Matt Williams on Universe Today. And speaking of dark matter, astronomers have found a lot of variation in dark matter. Like on average, there is about 10 times as much dark matter as there is regular matter in the universe, but this amount of dark matter is not evenly distributed. Astronomers have found examples of galaxies which are almost entirely only dark matter, and they found other examples of galaxies where all of the dark matter has been stripped away from them, and everything in between. So we got a new image from the Hubble Space Telescope of the ultra diffuse galaxy FCC 224. And galaxies like this are relatively common in the universe, and they're known to have like not a lot of stars, but they do have a lot of dark matter, and so they're not very bright. And it appears that you've got the dark matter is kind of acting like the glue to hold this thing together, and so they are heavier on the dark matter side. But with FCC 224, it's very low in regular matter in stars, but it's also very low in dark matter as well. And so this has created a new classification of galaxy, dark matter free ultra diffuse galaxies. And so we're learning that the universe can come up with every possible combination. And we've got a story about this on Universe Today from Dr. Brian Koberlein. We've got a couple of images to check out. First up, this is an image of the Uranus West molecular cloud. Is it Uranus West molecular cloud? It's one or the other, and I'm sure people will clarify it in the YouTube comments for me. And this is a star-forming region with dark molecular clouds. And these are some of my favorite kinds of nebulae. When you think about the really bright nebulae, like the Orion Nebula or the Eagle Nebula, you're seeing gas that is heated up to the point that it is turned into a plasma, it is blasting out electrons, and you're seeing the light from this nebula. But if the gas has had a chance to cool down, then it turns into the molecular form of these atoms. They actually collect together into various molecules. And they're dark, they don't emit light, and in fact they block light, they're opaque to light. And so you're going to get these molecular clouds, and inside these molecular clouds are protostars. And so in this nebula that we're seeing, there are actually lots of newly forming stars. And over time the stars will heat up, they'll heat up the gas around them, eventually it will start to glow, and they'll clear out all of that dark nebula material. And this picture was taken by the Dark Energy camera. That has taken just some incredible images of space. We've got a great story about this from Carolyn Collins Peterson. And if you're up for a challenge, it is Titan Shadow season. Now, we might have mentioned this a couple of weeks ago. Maybe I didn't. I should have. Anyway, Saturn is at a fairly significant axial tilt, and it takes 30 years to complete one orbit around the sun. And so from our perspective, we watch as the angle of the rings changes over the course of that entire 30 years. So we get times when the plane is seen at its maximum angle and it's just like gigantic rings. And then other times when Saturn passes and we see the rings almost edge on. It's if the rings disappear. And it's during that edge on time when Titan, which is Saturn's largest moon, is able to cast a shadow on the surface of the planet. And we've entered Titan shadow season within the last couple of months, and this will continue on until late September. Every 16 days, Titan comes back in front, the sun casts a shadow on Titan, and we're able to see it from our perspective here on Earth. And so if you're an amateur astronomer, you've got a telescope that is large enough for you to be able to see the shadow cast on Titan, you've got about 4 months to be able to observe this about 8 times. And then October 3rd, there will be a partial shadow, and then we won't see it again for another 15 years until we wait for this edge-on ring season for Saturn again. And so if you want more information about this, we've got a great story from David Dickinson on Universe Today. While you're watching this week's Space Bites, I am writing my weekly email newsletter, The Guide to Space. This is where I summarize the dozens of stories that we are writing on Universe Today. You're only seeing a fraction of the reporting that we're doing on Universe Today. For example, the GEO 600 gravitational wave detector is getting a big upgrade, and this is going to allow it to see higher frequency gravitational waves and other kinds of exotic events happening in the universe. We've got a story about that from Andy Thomaswick. James Webb has completed a huge survey of the earliest galaxies. I've mentioned several times this Cosmos survey, and this is something that James Webb is doing, where they're looking at lots of galaxies, building up lots of information for astronomers to study. They've got thousands of galaxies in this survey, and they've completed their first version of this. We've got a story by Mark Thompson. James Webb may have found a supermassive black hole in the southern Pinwheel Galaxy. This is a story by Evan Goff on Universe Today. A huge molecular cloud found close to the solar system. I mentioned earlier about molecular clouds, where you get clouds that are cold enough to form molecules, and they're very cold and very hard to discover. And it turns out there's a gigantic one that if we could actually see it, it would be way bigger than the moon in the sky. And we've got a story by Mark Thompson about that. Webb confirms the coldest exoplanet ever found, orbiting a white dwarf. This is a story about an exoplanet that is orbiting around a white dwarf, and it turns out it is the coldest exoplanet that has ever been found. We've got a story by Matt Williams about that. So if you want to get access to those additional stories, sign up to the newsletter. I send it out to 70,000 people every Friday. I write every word. There's no ads. It's completely free. Go to universetoday.com/newsletter to sign up. Every week, we do a longer version of this video that we call Space Bites Plus, and we release it on Patreon. It has one additional story, and it is available completely for free. So you don't need to log into Patreon to watch it, and I will put a link into the show notes so you can watch that version. And this week's bonus story is all about a Soviet-era Venus mission that's going to re-enter the atmosphere in May. You know I'm excited about the Vera Rubin telescope. Well, I just interviewed the director, and so I'm going to talk a little bit more about that. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Barely Griffin, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nelson, David Gilton, David Matz, Dustin Cable, Evan Pro, Greg Feely, Hans Schultz, Hudson Ward, Jay Graves, James Clark, Jeremy Matter, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Modzo, Paul Robach, Ren Kaidu, Robeck, Sean Sargent, Stephen Fowler-Munley, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I finally got to interview one of the people that I've been chasing for a long time, and that's Edward Ajar. He is the director of the Vera Rubin Observatory. And if you've been living under a rock, Vera Rubin is this incredible new observatory that's being developed down in Chile. It is going to be able to observe the entire night sky. Every few nights, it will be observing down to an incredibly dim magnitude and just producing petabytes of data that then astronomers will be able to dig through to find a million supernova, all of the asteroids, Planet 9, and then just all of the things that the universe was doing when we weren't looking. And so we have completed our editing on the video, and Monday we will be releasing this. So stay tuned. I don't know if you avoid watching our interviews or whatever, but this one is special. So when you see it coming next week, make sure you give it a watch. All right, we'll see you next week.